Hello, my name is Hang Ridley, and my talk today is testing your software OWASP ZAP. If this wants to work, great. So I'm going to give a short introduction about myself. 6 years ago, I graduated from University of California, Santa Barbara with a degree in physics and another degree in art history. I intentionally wanted to become a teacher. I even finished a teaching fellowship abroad, but it did not work out for me. So I started working in education, as that is my passion, and I started as a staff member. And then one day I had a work project to redo a website, and that's kind of where my love for software engineering really started to grow. I began taking IT classes at the local community college, and at the same time I enrolled in Flatiron School's online web development program. I loved it so much that I applied to the Master of Software Engineering program at Penn State. I was accepted and I started the program in January 2019. I'm still in it. I graduated in December and I'm pretty stoked about that. I started my first official software engineering job a year ago at an ed tech company, and this all led to me kind of just here today giving this talk. So I'm really thankful for all of the opportunities and everyone attending this session. So that's my quick bio. So let's do a quick icebreaker in the chat. How many of you have visited that Have I Been Pwned.com websites? And, you know, did you find any of your emails on this website? Were they, connected to any of the data breaches that have happened? How did that make you feel? So what are you going to do about it as a consumer? And if you're a software engineer or developer, like, what are you going to do about it? So for me, I, wasn't aware of all the security issues and risks. So I kind of took it upon myself to learn more. And that's kind of what helped me. That's why I decided to apply to a master's program to kind of learn more about software architecture and how I can do better to build better software for users. So not seeing any responses in this session, but that's fine. This is going to be mostly a demo, but I wanted to go over a couple of definitions that you would need to know beforehand. So let's get started on application vulnerabilities. So a vulnerability is something that a hacker can use to exploit and harm potential users of an application. 84% of software breaches are at the application layer, so between the user interface and other client-facing consumers, and then the set of available operations. So as a software engineer, we want to protect every layer, or as many as we can. We should provide validations for the requests that we get. Very, very quick overview. So OWASP. It is the Open Web Application Security Project. They have a couple of projects. One is researching the top 10 web application security risks every year. And these are the top 10 right now. So I'll briefly go over these as well. So the first one is injection. That is when, untrusted data is sent to an interpreter as part of a command or query. This is to intentionally trick the interpreter into executing the unintended commands or providing data without proper authorization. Next one is broken authentication. So sometimes authentication or session management mechanisms are not implemented correctly. So this will allow attackers to compromise passwords or session tokens, and ultimately letting them assume users' identities and make malicious requests on behalf of the unsuspecting user. Sensitive data exposure is when we have weakly protected data, when someone isn't using encryption at rest or in transit. This makes it very easy to conduct credit card fraud, identity theft, or other crimes. So a simple example of this would be when you're submitting an HTTP form of your credit card information. Anyone can access this using, ZAP, which I'm about to show you, or any other application security tool. So moving on to XML External Entities. So there are some outdated or poorly configured XML processors that can be used to evaluate external entities in your XML documents. These are used to disclose files or used for remote code execution and denial of service attacks. Broken access control is basically when users can do something that they're not allowed to do. Hackers can exploit this vulnerability and then access unauthorized functionality or data. A very simple example is when the shipping department manager can access the payroll files. There's no connection between the two, so the manager should not be allowed to access those files. So next one is security misconfiguration. This is the most commonly seen issue. Sometimes we just don't have secure default configurations, or somebody just has open cloud storage, or there's more information in the HTTP headers, or they're misconfigured. Or there are, error messages that expose more information that the hackers can use to devise an attack. Cross-site scripting is when hackers execute scripts in the victim's browser, and that can hijack the user's session and also make requests on behalf of the unsuspecting user. Insecure deserialization, that often leads to remote code execution. They can also be used in conjunction with some of the other attacks or some of the other flaws here to perform other attacks, as I mentioned. Using components with no vulnerability. So say you're using a library that suddenly or has a vulnerability, they release a patch, you don't install the patch because you didn't hear about it, or you weren't sure what it was about, you didn't have time to do it, and that makes your application vulnerable because someone who knows about the vulnerability can now log in or write a script or devise some sort of attack that against your application. The last one is insufficient logging and monitoring. So you can log activity with like Datadog or Rapid7, but you also need to include detection methods about unauthorized requests and how to flag that sort of requests. This would help you monitor if you had any hackers already in your system. So this is a really quick overview. I did include links to the content that I'm using here at the end. So very, very quick. So with all of these security risks, there are data breaches, and these are the four most, big and recent ones that came about in the last couple of years. So Heartland Payment Systems in 2008, they are a payroll processing company, and they were subject to a SQL injection attack. This led to 134 million compromised credit cards, and they eventually paid out $145 million in compensation. So that's a lot of money, and just because of one attack. One person eventually went to prison. Yahoo in 2014 had a broken cookie authentication process. Hackers were able to use recovery email addresses and nonces to generate access tokens. So they didn't need passwords to even make requests or access user accounts. About 3 billion users were compromised. They eventually paid $117.5 million in compensation as well. At the time, Verizon was trying to acquire Yahoo. So when this happened, they actually lowered their acquisition price by hundreds of millions of dollars. So in 2016, Uber also had a data breach. So hackers were able to access data through a third-party cloud-based service that Uber uses, and 4.1 million names and driver licenses were stolen of the drivers, but ultimately this affected 57 million global users, and their names, emails, and phones were downloaded. The hackers actually submitted this information through a bug bounty program of theirs, and they were paid 100 grand for this. The word kind of got out, so Uber actually eventually paid out $148 million to users in a breach settlement. And then one of the largest data breaches ever was Equifax in 2017. They are a credit bureau here in the US, and it was actually another application vulnerability on the consumer complaint web portal. They had actually hired a security consulting company at the time, and they gave them a list of items to fix or patch, configure correctly, and nothing was ever done. So hackers saw this as an opportunity, and they exploited the vulnerability. This affected 150 million consumers. Social security cards, or social security numbers, birthdays, physical addresses were, downloaded and accessed. This resulted in Equifax in spending $1.4 billion on internal costs like infrastructure, application, data security, and then another $1.4 billion in consumer claims. So, the total cost of just these 4 data breaches is $1.8 billion. So this is why we really want to be building secure applications. We want to make sure that our users are protected as well. So this is why I decided to do my presentation on software testing today. So what you would need is a website or any of these vulnerable or deliberately vulnerable web application like JuiceShop, BWAPP, and DBWA, or you can also generate a throwaway application like Ruby on Rails. Ruby on Rails is so easy to use. You also need to download OWASP ZAP. So let me give you one more warning. If you are using a website, please remember that you need to have permission from the website owners to use ZAP against the website. There are data privacy laws out there, and they differ from country to country, state to state, and city to city. So since there are laws, there are legal consequences. So please do your research if you really want to use a website. Even if you're using it for a bug bounty, for example, you have to read the fine print about what you're allowed to do. So just a fair warning for everyone out there. So I'm gonna do a quick overview, and that includes running JuiceShop and starting ZAP and giving a quick UI intro. So let's get started. Here is ZAP. I'm actually going to use this to open up the JuiceShop, which is running on a local server. We can start seeing our history window get populated with requests. Double click on section to be bigger. Which section? Let's try this. See, can you zoom in a little? Okay. So it doesn't look like I am allowed to zoom in using this. Sorry, folks. I did record GIFs so I can provide you with the slides afterwards to document what I did here. I'm just not able to zoom in. I'm so sorry. I hope it's fine if I proceed. Oh, yeah, I really wish I could make this bigger. Does that help a little? So, you know, once I started the browser, oops, not that one, over here, you can see that this is the juice shop that we can get from OWASP. You can clone the repository fairly quickly, run npm install, and does that look bigger? But here's the, okay, great. So we see that the sites on our left-hand sidebar has populated. The one that we're interested in is the localhost 3000. Just, you know, the stuff that it takes to get it started. You know, we see Git languages. So we can click on that, see the request headers for getting the data, and then we see the response, and we see that it's returned, you know, all the languages that we would see here in the upper right-hand corner. It is a little bit slow, so please bear with me. So the UI. So there's a lot of functionality here. They've tried really hard to make it as beginner friendly. So this is what you would see if when you first like open ZAP on your computer. Very straightforward. They have a bunch of blue boxes up here that you can use to configure your windows and rearrange them however you like it. I'm just going to stay with the default for now and not move around too much. So they offer these tabs as, you know, to start out with, but you can toggle show all tabs to show all the other capabilities. You can check out the WebSockets, add breakpoints, start an active scan, start a traditional spider, force browse, params, HTTP sessions, Zest results. There's a lot of functionality that I'm not going to be able to cover in today's tutorial or demonstration. So please, please download this if you're very interested. There's a wealth of tutorial videos out there by even Simon Bennett, who is the project lead for ZAP. They're very informative, also super nice. Okay, that was my very quick UI intro. So let's actually get started by creating a test user account. I'm just going to use test at example.com and password. I'm doing the exact opposite of what I just told you not to do, which is use password for your password. So this is a local application that I'm running on my computer. So, oh, okay. What about one? I was playing with this earlier. So, great. So test user 1 was created.com password. So, you know, works as a simple application, something that you would normally create on your own. And we can see that our items have populated in our, you know, baskets. Everything works like a regular website. But what we can do is actually see all the requests that were made by me clicking around. Like I added product 24 to my basket ID is 11. This is all, you know, crucial information when you want to change things. Like I could have used open and recent request editor. Let's say that I want to change this quantity to 4 and then run it again. Did that go? Let's see if that went. That did not go. So we can actually just redo this. Okay, this isn't quite going the way that I want it to, but we can actually log out, create another user, and we're going to try to use somebody else's credentials to log in using this breakpoint functionality. So just create another user, you know. So we want to create a breakpoint on this post request for a user login. We can see that in the request headers, and you know the parameters that are sent is the email and password, and then what we get back is a token, a BID number, and the user email. So we're gonna click on break, and this is fine. There's nothing dynamic about this string, so we're just gonna click save. So I just created test user 3, I believe. So we're going to try to log in. We should hit that break, and we do. The ZAP program would automatically pop into your view. When you have a breakpoint, you can configure it not to do that. I personally like it. Let's try to log in as test user 1. And we're going to press this to continue to the next breakpoint. We get a token, so that means it was successful. And we can actually confirm this if we go back to the UI, and we see that we've signed in as test user 1. Also, if you are using Juice Shop, you see that like whatever was in your basket before you had signed in will disappear. The caching on this is kind of odd. So if you notice anything weird, just like press refresh. You should be fine. See, we're back to 0. So let's kind of step it up. Let's log in. Actually, let me remove the breakpoint for this, so we don't have a break every time we log in anymore. Let's sign in as test user 1. And this time, we're gonna go through the checkout process. You know, put a few things in my basket. Checkout. This is my address. I want 1-day delivery. Wouldn't that be so nice? I've already inputted a credit card here. So we're gonna check out that. And we're just gonna place your order and pay. We're gonna go back to the history tab and check which request that correlated with. So it should be this one. You click on request. So in order to go check out, we send a post request with all of our parameters here. And we see the payment ID that is my credit card information is 8. So I want you to remember 8. So we our test user 2. We're going to log out. We're going to log in as test user 3, download.com. And then as test user 3, we're going to go through the checkout process like we did with test user 2, except I don't have an address for this person. Test user 3. Okay, I was surprised that worked. Green Avenue, Springfield. So like you can just put in any info. So test user 3, this is my address. One-day delivery again. I don't have any credit card information, but the point of this example is that even though we do put one in here, we are not going to use our credit card information. So let's click submit. Click that option, and we're going to go back to checkout. So before we actually press place your order and pay, what we want to do is create another breakpoint on that checkout item. So break. We're still going to use regex, but we kind of need to change this a bit. So we need to backward slash some of these items to make sure the regex works fine. 13. So we're going to want to use backward slash D plus for any digit. You know, the basket ID number is going to be digits. So I think this looks good. So we have a breakpoint. When I press this button, we should get a breakpoint. And there we go. So we see that the credit card information is matches payment 9. So that would be the credit card that I just inputted before. So we actually want to use somebody else's credit card information, and that number is 8. So this was test user 1's credit card information. So we're going to go ahead and press continue, and we actually do get an order confirmation number. We want to be able to, you know, if I was a developer, I would want to put a server-side validation that matches, you know, the owner of the credit card and the owner of the basket that's being processed right now. If they don't match, then we want to deny the checkout process and send back an error being like, you're not authorized to use this credit card, etc., etc. So I have one more example, but we're going to close this window, go back to Quick Start, and we're going to check enable heads up display or HUD. It's going to take a little bit long. I hope everyone is having a good time. Chat doesn't seem to be okay. So let's go back to the browser. Dismiss. So we're supposed to see a bunch of tabs here. There is a current issue with using HUD right now. You have to go to your about config. Please be super careful about what you're about to do. We want to change browser.tabs. Hello, Karen. Document channel. We want to toggle this to be false. And we're going to refresh this. And this is how you know you have HUD enabled. I recommend that everyone take the HUD tutorial. It's really great. You can continue to your target. And here we see all of the functionality that we had in the UI, but now in the browser. This would make, you know, testing your software a lot easier. You can do the same breakpoint function here in this one, show or enable, disable hidden fields. Page alerts show you the potential security issues with your application. We have the sites tree here as well. The sites tree was this item over here. And then we can start a spider. We can start an Ajax spider for those websites who use JavaScript heavily, like any application using React or Angular. We can start an active scan. We have site alerts for current security issues right now. You can click on it and see the low, medium, high. This will tell you what is going on with your web application, and sometimes it'll tell you how to fix it. So it's a great testing tool. Kind of running a little bit out of time, so I'm gonna click Spider. It's a really great tool. It'll kind of crawl through all of the possible links on this web application. And what's neat that you can see the progress here, but you can also switch back to the UI, see the progress, and then you can see which URIs that have been accessed so far. So it's a good thing that we did click that we wanted localhost 3000 in scope, because then if anything gets flagged for out of scope, it won't proceed any further. And that's great because, you know, I don't have access, or I don't have permission to access cloudflare.com. I think there's a few more, like fizz.com. I don't have access or permission from any of these website owners to access them. So it's good that the spider stops right there and then. Yeah, that was kind of quick. So do notice the progress bar kind of goes back and forth. So kind of interesting. We see that it's found that many URLs and that many nodes. It does kind of lag a little bit, but maybe because my computer is just a bit slow. But just running the spider will allow you to see which URLs are easy to access, which ones look interesting and maybe, you know, a point of attack. All of these are just assets. There's nothing that I really want in there. I think like the main ones that we would have wanted were the login and the checkout and the credit card information for this web application. Yeah, I think that was it. There wasn't very many things in the FTP files. I already looked, but yeah, the spider is really quick, right? It found 373 URLs and 245 nodes in just, you know, 2 or 3 minutes. Like I mentioned, you can actually look at all of the links in the site tree in browser, so you don't have to go back and forth. So those are my examples so far. I'm gonna go back to the presentation real quick. So I did record GIFs for about every little step of the process. So if you do want slides or more instructions on, you know, how to do certain things, I can provide you the slides. Just want to make sure that, you know, if something happened with ZAP, I was prepared for this presentation. So yes, if you want the slides, please connect with me via LinkedIn. Here's my LinkedIn. And then I believe it's also in my bio. So please feel free to watch out. I really appreciate, you know, everyone watching. I also included references and links to all the content that I've used today. And I want to give a big thank you to Anna and everyone at the Women's Tech Network and Deja Adams at Flatiron School. I really want to be here, you know, starting my software engineering career without Flatiron School. I want to thank Simon Bennett and the rest of the ZAP team for, you know, creating such an amazing product. I want to thank my professor at Penn State who introduced the software to me. I also want to thank my employer, Parent Square, who gave me my first job as a software engineer. And last but not least, my friends and family who supported my career change. So thank you all for watching and participating. Any questions? Great, thank you so much. I know it's a lot of content. I just wanted to, and these were just 2 or 3 things that Zach can actually do. There's a lot more, and I hope all of you do spend some time really figuring out. I mean, it's definitely a tool to continue using. A bit of a lag, but thank you everyone, and that's it. I hope you have a great day, and I'm excited for all the other sessions.